Hello everyone, welcome back to Educquiz. So we're on the fifth exercise on matrices. So the exercise goes by given the matrix M, where M is this, show that M is invertible. B, find M inverse, the inverse of M. C, solve the system of equations this. Notice that on this C, there's no say hence. When they don't say hence, you can solve the system of equation using your method. But I'm going to use the hence because in this case, hence will be easier. So let's start with the first one. A, show that M is invertible. Firstly, what is an invertible matrix? An invertible here means it has an inverse. So how do I show that it has an inverse? What is the formula for the inverse of the matrix? M inverse is equal to 1 on its determinant times the adjoint of the matrix N. For it to have an inverse, this determinant of M must not be 0. It should not be 0. So the only thing to prove is that the determinant of M is not 0. So if the determinant of M is different from 0, then it is invertible. Because it is only in a case where the determinant is 0 that it won't have an inverse. Because 1 divided by 0 or any number divided by 0 is indeterminate. It does not exist. If you punch your calculator, you see math error. So let's look for the determinant and check if it is different from 0. So we'll copy back M, 2, 3, minus 5, 1, 2, minus 1, minus 1, minus 1, 5. So what is the determinant of N? We have been doing it since. So it's plus 2, which is 2. We cancel the row and the column. You have 2 times 5, 10 minus 1 times minus 1, 1. Then minus 3 into, cancel here the column and the row. You have 1 times 5, 5 minus 1 times minus 1, 1. Then you have minus 5. The sign here is plus, but since the number is initially minus 5, you write the minus 5. Minus 5 times plus 1 is minus 5. So minus 5 into, you cancel here and cancel here, you have 1 times minus 1, minus 1 minus 1 times 2, minus 2. So we have the answer as 2 into 10 minus 1 is 9, minus 3 into 5 minus 1 is 4, minus 5 into minus 1 minus minus 2 is the same like minus 1 plus 2. This is the same like minus 1 plus 2. When I said already, when you see this minus and minus close to each other, it's same like cross. So it's same like minus 1 plus 2, which is 1. So here you have 18 minus 12 minus 5. 12 minus 5 is, okay, 18 minus 17, which is equal to 1. So here we consider the determinant of M is, and it is not 0. So from here, when you have the answer of determinant as 1, you can conclude hence N is invertible. M is invertible since its determinant is 1. So this is how you conclude it. So we are done with A, which was A actually. So let's move to B. B says you should find M inverse. So B, M inverse. To find M inverse will be equal to 1 over the determinant of M times the cofactor transpose of M, or the aggregate or adjoint. So let's find the cofactor transpose. So to find the cofactor transpose, or to find the cofactor of M, the cofactor matrix of M, I'll have to find a cofactor at each point here. So let's start. I'll find the cofactor at 2. The cofactor at 2, this 2 will be 10 minus 1, which is 9. You can check and see that it is this. We did this already when we were doing a determinant. So we should retain that on the cofactor, we don't consider this 2 again, or this minus 3, or this minus 5. We don't consider them. We consider just what is inside with the signs. So the sign will be plus, minus, plus, minus, plus, minus, plus, minus, plus. So you put the signs there. So the cofactor here is 9 plus 9. So you have 9. The cofactor of 3 is 5 minus 1, 4. But the sign is minus, so you write minus 4. The cofactor of minus 5 here is what is inside here. What is inside here is 1. The sign is plus, so you write 1. Then you find the cofactor of 1. Cofactor of this one, you cancel here and cancel here. Here the sign is minus. You cancel here and cancel here. You have 3 times 5, 15, minus 3 times 5 minus 1 times minus 5, 5. Minus 1 times minus 5 is the same like plus 5. So 15 minus 5, which is 10, but you retain the sign. The sign here is negative, so you put the negative outside. Then you continue with the cofactor of 2. Cofactor of 2 here, let me just write a 10 here. 15 minus 5 is 10, so that will be minus 10. So the cofactor of these 2 here, you cancel here and you cancel here. You have 2 times 5, 10, minus, you have 2 times 5 minus 1 times minus 5, which is 5. So that will give 5. The sign here is plus, so I'll leave it as 5. The sign here is minus. To find the cofactor at 1, you cancel here and here. You have 2 times minus 1, minus 2. The sign is minus, let me just put it. 2 times minus 1 is minus 2, minus 1 times 3, minus 3. So, minus 2 minus minus 3 is the same like minus 2 plus 3. Minus 2 plus 3 is 1. So, all of what is inside this bracket is 1. Since there is this minus outside, you can just replace all of it by minus 1. So, we find the cofactor of negative 1 here. Same, we cancel here and here, we'll be left with 3 times minus 1. Minus 3 minus 2 times minus 5 minus 10. So the sign here is positive, so I don't write any sign behind. It's positive. 3 minus minus 10 is minus 3 minus minus 10 is the same like minus 3 plus 10. That will give 7. So next, let's find the cofactor at minus 1. We cancel here and here, we have 2 times minus 1. Here the sign is minus. Cancel here and here, you have minus into 2 times minus 1, minus 2, minus 2 times minus 1, minus 1 times minus 5, minus 5. So that is 2 plus 5. Minus 2 plus 5. That will give 3. Since the sign is negative behind, you put minus 3. The sign here is negative. Remember, here is plus, minus, plus, minus, plus, minus, plus, minus, plus. To recall, you can just put the signs everywhere. So don't forget, you can just put the signs everywhere. But for some people, it's going to confuse. So, well, I'll advise to put the signs everywhere. So, let's find the last coefficient of 5. The last cofactor at 5. You cancel here and here, you have 2 times 2, 4. The sign is positive, so I don't put any sign there. 2 times 4, 4 minus 1 times 3, 3. 4 minus 3 is 1. So I can just keep it as 1. Okay, so we are done with the cofactors. So what is the cofactor matrix of m? We copy all of these values. We have 9, minus 4, 1, minus 10, 5, minus 1, 7, minus 3, 1. So that is the cofactor matrix of m. So when we find the cofactor matrix of n, we should find its transpose. So what is the cofactor matrix transpose. So the rows become the columns and the columns become the rows. So this 9 minus 4, 1 becomes 9 minus 4, 1 vertically. Then minus 10, 5 minus 1 become minus 10, 5 minus 1 vertically. Then this 7 minus 3, 1 becomes 7 minus 3, 1, just like that. Okay, so we are done with this. We have our determinant to be 1. You can just put it somewhere. You can cancel this. I don't know where. Okay. I can cancel this. Then M inverse. What is it going to be? Since we already have our cofactor transpose, we can find M inverse. M inverse will be 1 over the determinant times the cofactor transpose, which is 1 over the determinant is 1 times the cofactor transpose is going to be this. So means M inverse is just going to be 1 over 1 is 1. So 1 times anything is anything. So we just write the 9 minus 10, 7 minus 4, 5 minus 3, 1 minus 1, 1. So that is M inverse. Okay, what does the C part say? We're done with the B. Solve the system of equations 2, 3 minus 5, 2, 3 minus 5, 1, 2, minus 1, minus 1, minus 1, 5. Same like this. So you see here does not say hence. So you can choose to solve this using the inverse method given you already have the inverse. Or you can choose to solve it using Cramer's rule. Finding the determinants at these points on the first column, second, and third. So you can choose anyone since there's no say hence. But if you hear hence, you must use this answer to find it. So I'll use the hence, then I'll use the Cramer's rule. So using the hence, using the inverse method, we are going to have, since we already have the inverse, we have, let's put that in matrix form. When you put that in matrix form, you see that it will be the same like M into X, Y, Z is equal to 2, 1, 0 if I somewhere. 2, 1, 0. Okay. So to find X, Y, and Z, it will just be, you divide all through by M. You divide this by M. You have X, Y. Which is this. Simple as that. So let's calculate it. So M inverse, X, Y, and Z is going to be this times M inverse, which implies X, Y, Z. Let me write it here, which implies X, Y, Z is going to be 210, 210 times M inverse, which is this 9 minus 10, 7 minus 4, 5 minus 3, 1 minus 1, 1. So let's find X. X will be equal to, multiply this column by the first row, you have 2 times 9. Well, you have 2 times 9, 18, plus 1 times minus 10 plus 0. So 18 minus 10 is 8. So we have our X as 8 actually. Y will be equal to, multiply the column by the second row, you have 2 times minus 4 minus 8 plus 5 or 0. So Minus 8 plus 5 is minus 3. So you have y equal to minus 3. So let's do same for z. What is z going to be? Multiply the column by the third row. You will have 2 minus 1. So z is equal to minus 1. So a final answer, you can either leave them like this, but I like to do x, y, z is equal to 8 minus 3 minus 1. And you leave it like this. So you could either do it like this or using Cramer's rule. You see that doing it like this, when you already have the inverse, it's just normal multiplication. You multiply just one time, and you're going to have the answer. Using Cramer's rule, it's as simple. Well, you're going to find many determinants. You're going to find the determinant many times. So, well, you can still choose to do it using Cramer's rule. Let's keep our answers. X equals 8, y equals minus 3, z equals minus 1. Let's use Cramer's rule and see if it will give the same answer. Okay, so let's find using Cramer's rule the values of x, y, and z and see if it's the same. So using Cramer's rule, you see that the matrix is going to be this. So the formula to find x using Cramer's rule and y and z is the same thing. You have the x and the m, where the x is that matrix M where you have replaced this answer by the first, you have replaced the first column by this answer. So let's do it. What's the x? The x will be the determinant of, you take these answers and put it on the first place, the first position. You have 2, 1, 0, then you recopy the rest. 3, 2, minus 1, minus 5, minus 1, 5. So let's find that determinant. That will be equal to, you have 2 into, you cancel here and here, 10 minus 1. So plus 2 into 9, that's 18. Let's write the 18. This is minus 3. Minus 3 into, you cancel here and here, you have 5. Minus 3 into 5. Then that is plus 5, but since it is minus, you write the minus 5. Minus 5 into, you cancel here and here, you have 1 times minus 1, minus 0 times 2, 0. So it's minus 1. So you have 18 minus 15 plus 5. Minus 15 plus 5 is minus 10. So you have 18 minus 10, which is equal to 8. That's the value of x. X is equals to the x on the m, but the m is 1. Well, the m is 1. We did that when we were looking for the inverse of m on exercise 8. So we can see that x is the same value as that of. We can find y. Well, I'm not going to wipe. I'm just going to wipe this. Y is, we replace the second by the answer instead. So this second one is going to be y. And the first one remains itself, 2, 1, negative 1. So 2, 1, negative 1. That's going to be 2 times, you cancel here and here, you have 5. 0 times anything is 0. Minus 2 times, you cancel here and here, you have minus 5, minus 1. Then minus 5 into, you cancel here and here, you have 0, minus 1. That is 10 minus 2 into minus 5 minus 1 is minus 6. Minus 5 into 0 minus 1 is the same like plus 1. We explained this many times, right? It is minus and minus, it is 1. So that is 10 plus 12 minus 5. So we are on z. we're looking for z. Actually, 2 minus 1 is 1. Here, I'm sure I've spotted it. So the value of z here is 1. 1. We're on the z. Let's find z. Let's find the determinant. The z, you have 2 into, cross here, 2 times 0, 0, minus 1. Then minus 3 into, you cancel here and here, 0 minus 1 plus 2. You cancel here and here, minus 1 minus 2. So that is going to be 2 minus 3 plus, here is 1. 1 times 2, 2. So 2 minus 3 is minus 1. Minus 1 plus 2 is 1. So you can see here that z is equal to the z. The z and the m, which is equal to 1, which here shows that z is 1. So we solved the simultaneous equation using the two methods. Now left on to you to choose which method you want to use to solve it, except when they showed you hands. So thanks for watching these exercises. My name is Chenta Gabriel and I'm a level 400 student at the University of Buya, Department of Computer Engineering. Thanks for watching and keep learning with us on Educquiz.